in the first video, we're going to be looking at national pole relationships. I'm going to work through the Greif High School sheet, and then I'm going to work through the Dalkeith sheet as well. So this should give us plenty of practice on the relationship section. So first of all, we've got straight line work. So copy and complete the table below for these different points and then plot it. Very straightforward. So let's just quickly look at what we're going to be plotting on. So here's a blank standard Cartesian grid, as we call it. The x-axis is the horizontal and the y-axis is the vertical. We've got positive x's here, so that's 1, 2, 3, 4, 5 up to 10, and then negative x's down to 10. Positive y's up in the vertical, and then negative y's down here. You'd always plot x first and then y. So say I write down 2 and 3, and I write down negative 4, negative 5. Let's try and plot them. So 2, 3, we go along 2, and I go up 3. So it's going to be this point in here. And then negative 4, negative 5, I go back 4. So 1, 2, 3, 4, and then down 5. 1, 2, 3, 4, 5. I could then join these 2 points with a line. The software is actually quite rubbish. There we are. And I could join those 2 points. So it's as simple as that. X on the horizontal, Y on the vertical. Draw your points and draw a line. Nothing complicated. Okay. So can you move this? No, I can't move that. That's alright. Okay. So if we want to fill in this table, all we do is substitute in for x. So y is equal to 3x is our equation. I'm going to do y is equal to 3, substitute in for 1. I'm going to substitute in for 2, and then I'm going to substitute in for 3. So instead of x, I've put in 1, 2, and 3. So 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. Simple as that. 3, 6, and 9. And now I'm going to go off and plot those points. I'm going to plot 1, 3, 2, 6, and 3, 9. So let's see, there's a x-axis and the y-axis. So 1, 3, I'm going along to the left 1, I'm going up 3. For 2, I'm along 2, that's going to take me up to 6. And finally, I'm going to go along 3, for x is 1, 2, 3, and then up to 9. So 6, 7, 8, and then 9 up here. I could then draw a line through these points. And this is when you're sketching. In real life, it's actually probably easier than on the computer. And if we look at this, I could check to see if I've done it right. Because what if I substitute in x is 0? So for the line y is equal to 3x, when x is 0, 3 times 0 is 0. So it does go through the point 0, 0. That was good. What if I did the point negative 1? So it would be 3 multiplied by negative 1. Well, 3 times 1 is 3. Positive times a negative is a negative. So that would give me negative 3. So let's see if that's worked out. So there's negative 1, and I go down 3. Yep. So this line looks good. So nothing complicated at all. All we're doing is substituting a value in for x and then plotting. Let's miss this one. We'll go for a slightly trickier one. Okay, so we'll do 3x take away 2. So if I put in 1 here, that's going to give me 1. Sorry, 3, yeah. 3 times 1 is 3. Take away 2, finishes off on 1. If I put in 2, that's going to be 6 take away 2, give me 4. And if I substitute in for 3, 9, take away 2, it's going to be 7. So all you do to fill out this table is to substitute in the value of x into your variable. Simple as that. So let's go over and plot this then. See if I can remember those numbers. So what was that? 1, 2, 4, 3, 7. 1, 1, 2, 4, and 3, 7. I'll do this one here. So 1, 1, 2, 4, and 3, 7. So 1, 1's down here. 2, 4 would be over here. And 3, 7 would be here. And then you can draw your straight line. This is hopefully more accurate than my program will allow. That's about right. And this was for the equation 3x take away 2. Actually, it's quite good practice that to really just, once you finish writing it, you could label up and say y is equal to 3x, and that's probably a good idea. So let's just check if my line looks good. So let's try and substitute in for 0. Okay, so 3 times 0 is 0. And if I take away 2, there we go, I'm on negative 2. So when x is 0, which is this line here, I do end up on negative 2. Let's try another one. Let's say if x is negative 1. 3 times negative 1 is negative 3. And if I take 2 away from that, that gives me negative 5. So for x is equal to negative 1, I would expect y to be negative 5. So there's negative 1, and then 1, 2, 3, 4, 5. So this looks good actually, despite the technical issues of drawing the graphs. So I hope that was helpful. If you need to revise for that section. More. The only other thing that's worth noting are these special cases. So I'm just going to go back to, so that's for horizontal and vertical lines. I'm just going to go to this graph here. If I draw this line, yeah, it's actually very, I'm going to abandon that. It's actually very difficult to draw a line on this program. So I'm going to draw some points. And these points that I've drawn, you might be able to figure out what graph this is. So when x is 1, y is 1. When x is 2, y is 2. X is 3, y is 3, etc., etc., etc. I'm going to try and draw a line through these. Oh, managed it. So that line, when x is 1, y is 1, x is 2, y is 2, x is 3, y is 3. This is the line of y is equal to x. I always think that's quite a nice start for 10. So, this is something to try and visualize in your head, because if we look at the graph up here, y is equal to 3x, it's a similar graph, and it's very similar, but it's steeper. But when I draw 3x, I can draw 3x. It's very similar, but it's a steeper line, because the number in front of the x dictates the steepness of the line. So this isn't exactly y is equal to 3x, but that's kind of how it would look. And what happens is, the steeper your line gets, the higher to infinity this would get. So you'll end up with a line that's about, y is equal to almost infinity x as you get steeper and steeper lines. So this line becomes steeper and steeper, but it still goes through the origin. That number in front gets bigger and bigger. It's kind of the same but opposite when you go the other direction. So when you start to flatten your line out, I do apologise for how rubbish these lines are. When you start to flatten the line, instead of 1, we end up with fractions. We end up with y is equal to a half x, y is equal to a quarter of an x, until eventually you end up with y is equal to 1 over a million x, okay, effectively. So this number just gets smaller and smaller. So as you get a shallower line, like this, the number in front of x would get smaller and smaller. So they are kind of similar graphs, but this number in front of the x would get bigger as you get steeper, and then much smaller as you get flat. But then what happens when you've got a purely vertical line, or a purely horizontal line? So for the horizontal line, if you imagine any horizontal line, well, what's our value here of y? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so for this line, y is always equal to 16, isn't it? No matter what value of x you've got, if you've got -1, -2, 0, a million, it's always 16. So in this case, your graph is just simply y is equal to 16. It doesn't matter what value of x there is, because y is always 16. And for a vertical line, it's the same thing, isn't it? But for the x. So if I was to draw this line here, someone would say, okay, let's plot my table. Again, apologies, line. So -1, 2, 3, 4, 5, 6, 7, 8. That's -9. So if I plot my table, x and y, it doesn't really matter what value of y I've got. X is always -9. -9, -9, because when y is equal to, so let's say if I go here to y is equal to 1, it's -9. Y is 2, it's -9. Or if I go to y, if I go down to y is -5, it's still -9. So it doesn't matter what number of y you put in, your x number is always -9. So for those ones, x is equal to -9. So if you've got a horizontal or a vertical line, look at the number that you're hitting, and it's just that number all the way, isn't it? So your table looks quite odd because you've not got a difference in numbers, you've just got the same number all over again. So for your horizontal lines, y is always the same, and for your vertical lines, your x number is always the same. So for that vertical line, it's always this number here, and for the horizontal line, it's always that number there. So I hope that was helpful for graphs, and we'll move on to the next topic, which is going to be solve the equations. So for this one, there you go, y is always equal to 5, x is always equal to 3, y is always equal to 2. Simple. And you can't really get it wrong because the number that you're looking for, it cuts that axis, doesn't it? So we're cutting the y-axis, y is always equal to 5. Cutting the x-axis, x is always equal to 3. So the equation's kind of almost in your face a little bit. Yeah. And then for your non-horizontal and vertical lines, do this little table and plot out. So yeah, hope that was helpful.